All right, so 10.6, we're getting closer to the end. Segment relationships. In circles. So, the last section we talked about the angles like on the outside. Now we're going to talk about, segments. Actually, we talked about angles like on the inside, but so it'll be the same pictures. But now we're talking about the lengths of the segments instead of the angles. So the last section it was like, well, this angle in the middle was half, and then you added DC and AB arcs together. Now we're saying, well, how long is each one of those things? Okay, and so when the segments cross on the inside, you're going to multiply each part together. So AE times EC will equal DE times BE. Okay, so some of them will be simple. Others will have some letters involved, so let's look at one of those. Okay, so we have on the left side x plus 2, or the AE, let's do it in order. AE is x, and EC is x plus 4, and DE is x plus 2, and BE is x plus 1. So here's where, we're going to have a bit more algebra in some of these problems, especially like this side. So I have 1x when I do that, and 2x when I do that, so I have 3x altogether. And 2 times 1 is 2. So similar to a problem a couple sections ago when we had x squareds, when we go to move them to one side or the other, they disappear because they both end up being 0. And we end up with x equals 2. So sometimes, like on these ones, I think this is the section that I was thinking of before. No, it actually does say just solve for x. Okay, so to know if this is true or not, and this will come up on your test when we do a test. So if I had this picture and I plug in 2 for x, that makes that 2. And this bottom part, x plus 4, 2 plus 4 is 6. And then this one, 2 plus 2 is 4. And 2 plus 1 is 3. So if you look at 4 times 3 is 12. And 2 times 6 is 12. That has to happen. So if it says does this satisfy a theorem or something like that, multiply the numbers together, and if it works, then you would say yes, it does satisfy that theorem. If it doesn't work, if you got 12 equals 14, then something's off. So this, essentially what it would mean is this, even though I can't draw straight, it's almost like if this was 7, that it would have to go all the way down there or something like that. So just if there's numbers already there, just multiply them together, and they have to equal each other, otherwise it's not done correctly. Okay, so all your problems that you're going to do with this theorem, there are x's involved. They're not necessarily like this one where they're all x's, But obviously you have to have one of them be x because that's what you're finding. But set up an equation, and when the segments intersect on the inside, you just multiply each of the little parts together, and then you'll solve an equation. All right, so good news is that's kind of the end of the theorems. We do have one more section to cover, but there aren't a bunch of theorems in that one. So, okay. All right. Hope you're doing well. Have a good rest of your day, and we'll see you tomorrow. Be good. Excuse me. Okay. The other two pictures. So the angles, we had 3 more pictures here, but this one will only have 2 pictures. So we could have that one, 2 secants. We could have a secant and a tangent. And the other one would be 2 tangents, but that actually is a theorem in the very first section because that's like the ice cream cone theorem where the 2 tangents are equal. So this one is gets cut down into 2 pictures instead of 3. Okay, so here's like the big thing with this theorem. Remember, we're talking about the lengths of the segments. Outside times the whole thing. Okay, so on this one on the left, what's the outside? CB. What's the whole thing? CA. And then the other line, the outside, CD, and the whole thing is CE. Okay, on this one, what's the outside? CB, and the whole thing is CA. On the other one, what's the outside? CD. What's the whole thing? CD as well. So on the tangent one, you're going to have the same thing. So I think what the book does is it says CD squared. But I think it's easy enough to just, you're going to do CD times CD if you did squared. So just to kind of use this outside times the whole thing component, I think, it's better like that. Okay? So if we come over here and we had, the numbers might not jive with what the picture looks like, but okay, so the outside is 9, the whole thing is 20, 9 plus 11. The outside is 10, the whole thing is x plus 10. I don't know the whole thing, but I have to add them together. So this is 180. This one, distribute 10x plus 100. And then divide. And x equals 8. Okay, so you could again have some with, x's in more than one spot. Okay. Okay, so for over here on the right side, let's see. If we had, say this was x, and this was x plus 2, and this was 10. I just kind of made up the numbers, so hopefully it works out okay. So the top one, the outside is x. The whole thing is x plus 10. And then on the bottom part, or the tangent part, we have x plus 2 times x plus 2. So it's similar to that other one that we did, but so x times x is x squared plus 10x, x squared plus 2x plus 2x plus 4. So I can combine the 2 and the 2 and put 4. And just like the other one, if I subtract x squared, it goes away. Yeah, I'm gonna get a fraction, but that's okay. Subtract 4x, and then divide by 6, and I get x equals 2/3. 4 over 6 reduces to 2/3. So the process, you'll have one similar to that. The process is the same. I think it works out to be, x is 5, or, a whole number. Okay, but outside times the whole thing. And again, some of them won't have as many x's in there, so it should be easier. Like this should be the hard problem to do. There is one. Oh, I'm going to have you skip that one. Okay. Yeah, so I was going to say there's one that's kind of funky, but I'm going to have you skip that. So, okay. So outside times the whole thing. When the two segments intersect on the outside,